Alrighty. Good morning, everyone. I apologize I couldn't be there in person this morning. Mr. Green, I had full intention of being there, but a last-minute development kind of prevented that from happening. Today, we're going to be going over our third progress report for our third ion plastic detection system. Can everybody hear me?
Good, good.
Okay. Before we get into it, just kind of an overview of what we did in the last one. We had kind of narrowed down to three possible solutions, and the decision matrix we constructed had kind of recommended a two-camera system due to its decreased cost and pretty good performance in the other grading criteria. But after some input from the client, he made us aware that cost may not have been necessarily as important as we were making it out to be. So we kind of took a step back and kind of reevaluated some of our solutions. And we decided to go with the second highest graded option in the decision matrix. Go ahead and switch to the next slide. So what we decided as a team to recommend as a solution is a three-camera system. On the entry side, having two Dahua N42 B32 cameras, accompanied by two 6-inch LED light bars from GG Lighting. On the back side, given that we're trying to focus on the front side is the one that's we believe will be more likely to catch plastic contamination, we're only going to have one camera on the back side, same camera type, but we're going to have the same two LED light bars to make sure it's well illuminated and that it can see any kind of plastic contamination that might congregate on the back row of feed spindles. For camera protection, we decided to go with an optical grade Lexan 9034 lens cover, cut to 2.7-inch diameter little circles, the same diameter as the camera lens itself, in order to sort of kind of add a little longevity to the system and protect the camera lens while also making sure it can still see what's going on inside the module feeder. And this slide's kind of a mock-up of the orientation we had planned for our systems. So this diagram of the module feeder itself shows on the front side the lights and cameras, and it's constrained by the height of the opening where the modules actually entered the machine. So that was why they're out of alignment with the rear system. Obviously, due to this, we're going to have to angle them downward because we had talked as a team and with Dr. Harden, and we thought that the lower 3 or 4 feed modules on each column would be kind of where we want to focus, kind of be the target area. So that's why those red arrows indicate the angle at which the camera and the lights on the front side are going to be angled to observe if there's any plastic contamination there. On the rear system, that constraint doesn't necessarily exist. So we can place them much lower, ideally right directly in front of those lower 3 or 4 feed rollers in order to kind of just get a lot closer and be able to detect the plastic contamination that gathers there. And we obviously want it as low as possible, and that's why the reason they're out of alignment. And with that, I'm going to pass it over to Reed, who's going to go over some vendors of our possible components.
Yes, like Caleb said, I'm Reed Machek, our vendors and the components of our system here. The Dahua camera can be bought directly from Dahua. It comes with minimizing bandwidth technology. Minimizing bandwidth pretty much just gets rid of the glitching thing. That information is constantly being sent over to the control panel. It does this without affecting quality or durability. The camera is compact. It's got a 2.8 millimeter lens, so this can fit tight spaces such as the model feeder. It comes with Starlight technology, which means it can sense applications in very low light or very bright light, being that we're going to have light bars pointing down inside the module feeder. It is part of the Arctic Pro series. It has capability of functioning up in conditions negative 40 degrees. We might not get that here in Texas, but if this application reaches a little further up north and winters up north, it can operate under those conditions. And the lighting vendor, it can also be purchased straight through the company GG Lights. It is also compact. It's got a 6-inch by 1.75-inch housing. It comes with a 7-watt LED chip and a 4D projections. The 4D probably doesn't make much sense just looking at it, but the 4th D is the ability to project green light, which green light has the ability to make plastics reflect. Kind of maximizes our operation here. Comes with 2600 lumens and only runs on 3.5 amps. and that can be beneficial and advantageous in a gym. Stainless steel mounting brackets also come with it, and it comes with military grade breathers that light, if it's putting off a bunch of light, making heat, those breathers allow the light from overheating and burning up the bulbs. Next one. The lens vendor can also be purchased straight through the original producer, Total Plastics. It is high optical quality. It ranks highest in its quality, which is free from foreign matter, bubbles, and distortion. Being that the camera has to record through its lens and the lens cover, so we felt as a team this would be very advantageous. And coating, it's got a coating ability. You can put a plastic coat over it. The recommended coating is listed with the product. This coating helps with reflections, being that the light bar is in there, so you're not picking up any unwanted light. Strength test, it is also military grade strength, and it comes with a 5-year warranty, so that will also be beneficial inside of the gym. Now I will pass it to you, Daniel.
Howdy y'all, like I said, I'm Daniel, and I'll be going over a bit of our economic analysis for this solution. So, based on our research, we found that the average price for upland cotton in the 2019-2020 year was 60.4 cents per pound. This was already approximately 10 cents lower than the year before, which is already a problem, and so farmers can't afford to be losing even more money due to plastic contamination. An article in Southwest Farm Press estimated the loss in plastic in the 2019-2020 year would be between 5 cents and 7.75 cents per pound. Another source that I found stated that assuming a 4 cent per pound loss due to plastic, with a crop of 20 million bales, there would be a $384 million loss, which is just insurmountable. And being able to detect the plastic early on would help lower the profit loss experience, obviously. So as far as our individual components that we're looking at, including everything except for the metal that will be used for the mounting brackets, we'll have the toggle clamps, 6 of those for the 3 different cameras at a total of $61 roughly. And then we'll have the piano hinges at a total cost of $5.44. The LED lights are going to cost $399, basically just $400 total. The camera itself will be $404 total, and then the Lexan will only cost $7.42, and that's for 2 sheets of 12 by 12 inch sheets in order to, in case, one of them gets scratched up or it doesn't get cut exactly right, there's extra left over to use on the cameras. So as far as the individual components are concerned, the total cost for this system is going to be $878.60, which this is not including, like I said, the mounting bracket, which we'll get into a little bit more when we do our final presentation. Operating costs are going to be negligible and dependent on what each gym pays, depending on where they are, given that one camera is not going to take up much power compared to everything else that's going on. And then I'm going to pass over to Wayne and he'll go over the last little bit.
Also wanted to mention a little bit about the operating costs. One of them, obviously, of course, is the electricity, as Daniel mentioned, but also the costs of the time that it takes to take a snapshot of the module feeder. You have to stop the feed in order to do that. But as we understand that process already happens, so we have a little bit of a window already available to us of time that isn't going to reduce bales per hour as much as would be negatively impacting the gym. Of course, we can get more of that information from Mr. Green. Also wanted to go forward with a little bit about the potential savings. So of course, we don't have everything fully nailed out. We have a little bit about the differences in price that you see from seeing that 71, 72 class cotton from the USDA classing office. But as we understand, it's just as much about saving money in the system as also about maintaining a reputation for the quality of Texas cotton. It's the reason why the industry has been able to be so successful. And going forward, not only do we want to Of course, we want to maintain profitability of the gin, but we also want to maintain that perceived quality of the cotton that's being produced. I mentioned the 7172. It's not on the slide, but I just want to talk about it. So previously, cotton that was of lower quality was based on just the color grade, and it was 6162. So the 6 is just the color grade. The 1 and the 2 are for light and heavy on the contamination. I believe since the 2018 season, it's been updated to the 7172. 7 is specifically for extraneous matter due to plastic contamination. And again, the 1 and the 2 are for light and heavy. So it's even more prevalent. It's even easier to understand how much plastic contamination is available. That information is available based on region. So as far as Texas cotton goes, that's also part of the potential savings is, again, not only saving the profitability, but maintaining that perception that high quality cotton is produced out of the state. So just to recap a little bit before I go into next objectives. So we're going to be proceeding with, it would have been the second system from our decision matrix from the last progress report. It's going to have 2 cameras at the entry point of the module feeder and 1 at the rear. There's also going to be the light bars on both ends, the entry and the rear. And then those camera lenses will be covered by the optical grade Lexan just to minimize reflection as well as protect the camera lens from any debris flying around inside. Our next objectives will be to have our final faculty meeting with Dr. Harden to further flesh out the recommended solution, as well as begin analyzing some of the uncertainties and develop our implementation plan. So this is going to go into more about how we're going to get that mount to be able to go flush up against the side of the module feeder, as well as to kind of flesh out more of those electricity costs and other costs that may be inhibitors to us. Our next meeting is going to be on April 6th, and if you have any questions, we'll happy to answer.
Y'all go back to the side view of the cameras. So, are those the front cameras? Are they mounted? It's hard to see without
Right.
view, but are they on the sides?
Yes, so they would be along the length of that.
Right, on
of
those
that space.
sidewalls?
Yes.
Yeah, okay. So you can adjust them up or down there.
Yes.
Wherever you need it. Okay. And you said there's a Lexan cap over the lens. So how do you seal that? The dust tends to find its way into any place it can find.
What we had something you do whatever.
Like talking about like implementation wise, like how you're sealing the Lexan to, I guess, the metal
To the camera.
to the camera.
So you don't get dirty between the camera lens and the Lexan.
Would you recommend it be up against the camera lens, or
I don't know. I'm just asking the question. I mean, it may be that you've got a gap in there and you're planning on somebody hitting it with arrows or something. That's fine. I'm just curious. I when I saw it, that was the first thing that popped into my head was I wonder how you keep the dust from getting between them.
Something we had discussed. We don't have it fully fleshed out yet, but on that mounting bracket, I don't know if we don't have the image on this slide, but if you
Yeah, I know
remember,
which one. You're talking about the USDA one that
yes. So if it has that hole that fits the size of the camera lens, we were thinking if we just have those cut up pieces of the Lexan available on hand, we could make kind of like a slot for that piece of Lexan to slide in to be flush up against the camera lens, but it's being held in place by the mounting bracket instead of being adhered to the camera lens. Does that make sense?
so they're not touching.
I think what Blake's trying to say is they'll be touching, but it'll be the actual Lexan will be held in place by the mounting bracket, so it'll have its own little bracket there. You can slide it in and lock it in place.
So that we can also
against each other. We'll just make it'll be real tight. If that makes sense.
So that we can also, if something were to happen where that piece of Lexan needs to be removed, if it's too badly scratched up, we can
Well, that's right. Yeah,
take off the security and put another piece in.
Something will come in front of it and scratch the. Okay. Yes. All right. Let's see. How hot does that light get?
I don't know. I don't know the
You
exact
said
answer.
heating bins, no, I wonder how hot it gets.
It's right.
To get hot enough to catch the cotton on fire, that's the important question.
I know it gets hot. I don't know the exact temperature, but we use it like my part at home, grinding hay and stuff, and we have
Your LED, yeah, the LED lights won't get as hot as your
It doesn't get as hot, but I mean it's still warm.
It
But
might be worth, getting a number and checking that
Okay.
against the flammability values.
Yes, we'll look into that.
Okay, let's see here. I'm really glad you brought up the cost of pausing. 'Cause I was sitting over here thinking, the cost of electricity, if you've got a 1 or 2 megawatt cotton gin, you throw a couple extra cameras on it, I mean, it's not changing the electrical.
Yes.
Even, you'll never see it, but the pausing, that is, I mean, that's worth it. It's kind of like the last problem. When you take the savings, when you talk about, potential cost of contamination and the 61 and 71 issue, I'm glad you brought that up. Now, 61 is actually contamination as well. There was a 61, but 61 can mean sticks and stems or leaf particles, and the mills don't care about that. They can get the sticks and stems out easy. But used to, they had a 61, they weren't sure if it was sticks and stems, which they care less about, or plastic. Now they got the plastic hanging out all by itself, and they'll, in some cases, they just won't buy them. So the cost of pausing, you guys worry about that. They worry about, man, how much, if you could come up with a kind of an idea of, well, pausing is going to cost about this much, but you're going to save this much, and that kind of puts their minds at ease about the whole idea of pausing, because it is expensive to pause it, but it's even more expensive to get bills. So I like that whole line you were going on, and I think you guys can expand that.
It comes a little bit from with what we talked about with Dr. Harden. Based on pausing, what he had mentioned to us is that as long as we don't pause long enough to where we run out of cotton in the feed control hopper down there at the bottom, then because there's cotton already there. So as long as we're not at a point where there's nothing in the hopper, then we should be kind of fine on the pausing.
One thing that came up last night, we were in, what the name of the class is, it's Kingman Safety Class though.
360.
360, yeah, 360. 360.
One of them.
One of those, it was a 3 and a 6. And we had our workers' comp guy in there talking about loss control and how to do those things. And he kept bringing up all these accidents that we've seen our whole injury profile shift with plastic. And so there's a really large safety component to this that honestly I hadn't even mentioned to y'all, because I don't know, I tend to segregate them in my brain, which is a mistake, right? Because I'm thinking, you guys can justify this on the cost alone, but there's a big safety component to this whole thing. Because these guys have to go in there and clean out the plastic, and when you pause and stop a system, and you have workers, when it pauses, the workers come in and then they go out and it starts again. Every time you do that, that is a safety issue. So there's a whole safety component to this. I don't guess I wouldn't really know how to quantify that, but it is out there.
Yes.
That's
Okay, team one, let's have your comments.
Yeah, Caleb, I thought your intro was solid, very well spoken, and Wayne, your potential savings section was really good. I thought it was very well informed. Y'all are doing a really good job of using like graphics and tables, in my opinion. It's just really easy for me to kind of get a solid idea of what y'all are trying to accomplish without having all the intimate knowledge that y'all have. So overall, yeah, I thought it was a great presentation. Everyone's presentation style was solid, and I enjoyed it.
Thanks, Doug.
Yeah, I really like the part in the economic analysis where y'all put I think y'all said if 4 cents were lost on each bale or something, you would lose like 384 million or something like that. But just putting that in perspective is crazy, and definitely need a solution for that problem. But yeah, good job, guys.
Yeah, like Doug said, I agree with especially this slide where y'all kind of show the diagram and show where the cameras will actually be for, maybe for somebody who doesn't know what a module, how a module feeder looks and what y'all are really trying to accomplish. It really helps get your point across. So I think that was effective. And then the slide where y'all kind of laid out, all the parts that you're going to need with the cost. I think having pictures kind of, I mean, we all know what a light bar looks like in a camera, but it just kind of to know the brackets and different things like that, just to visually see it. I think that was good.
Anybody else? How about Dr. Hart? You want to make some comments?
Yeah, I guess I'll be the economics guy today. If you want to go back, I think you had a slide where you showed kind of the discount per bale. Oh,
Either of these?
yeah. So you can probably want to get some updated information. You can actually get, is kind of Mr. Green was explaining, the bales with the 71 and 72 grades for plastic. The actual discount is published. It's the USDA cotton loan premium and discount chart. So if you just search for that, you should be able to see the actual amounts that if you have a bale that's is a 71 or 72 extraneous matter for plastic call, what the discount is. Now that probably underestimates things, as he said. If a bale has that, it may not get bought. So that's then it has no value, right? So or very little. But I'd update that. Also, you were mentioning with kind of the cost of using the system, and of course, as you pointed out, electricity is low cost for this and pretty much inconsequential. I think a little bit about the maintenance cost. He asked the question if about the dust, and there probably will be some maintenance in terms of cleaning, replacing lights. I'm not sure what it might be, but maybe make some estimates there. That's going to be probably more significant than any other actual electricity cost. So that's my only suggestion there.
Okay.
So I have one question.
Go ahead.
Okay. So now let's say you have an eye system, and what is your mechanism for detection testing? You can have some software or manually detect plastic based on the image, or you're gonna have someone sitting on the monitor just to keep monitoring things and plastic contamination.
It would be someone sitting in front of a monitor, because you have to stop the feed in order to capture an image, because when it's running, it's like snow flurry in there. So you have to stop the feed anyway to take a look and see how much plastic is is caught up in those bottom feed rows. So at that point, what Mr. Green told us is that the gen crew is able to remove that as long as we can make sure they can see it from the video feed.
Well, didn't Dr. Holt say at the beginning that if you could give him an image, he's got a system to analyze it?
Yes, we talked about that.
I'm pretty sure the USDA is happy with their analyzing system, but we need to get better pictures to analyze. That's what I remember him saying.
That's my question. Thank you.
You guys have a seat.
You ought to send Dr. Holt an email and ask him that. Yes, sir. I have to know this photo.
Okay. Good presentation, about 12 minutes long, right? What we're looking for. You guys had a good organization and transition between each one of you. You obviously are working together as a team. Let's see. Wayne, I really liked what you mentioned in terms of it's hard to quantify the economic impact of plastic, and as the National Cotton Council likes to talk about it, it's not really in terms of 5 cents a bale or 10 cents a bale. It's, our reputation is at stake, and where eventually, the mills won't buy Texas cotton or American cotton because of the plastic. So the reputation is a big deal, and that's very difficult to quantify. Unfortunately, you got to quantify it somehow. So you've got a good mechanism to do that, and Dr. Harden mentioned that. We'll talk about that in a second. My big critique about your project is that it's focused only on one or two components, lights and cameras. Like Jan brought up, how does the system work? How does it all go together? And how does the gen operator know when to stop things? Let me kind of overstate this. When I look at your presentation, if I was your client, it's like you're throwing some cameras and lights at me and say, hey, go put them together and good luck. There's got to be more to it. You don't really have a system. You have some components that you haven't connected yet. So because our major is ag systems analysis, I've got to emphasize this. Okay, so you've done some good research to come up with the right components, but that's only part of it. You've got to give the client a system that works. You've got to recommend a solution that's all put together. And so one aspect of this is drawings. That is what we call an elevation view. Okay, that only gives me one look at the system. And quite frankly, it's still pretty much a cartoon. Like, I don't even know what that box is over on the right of the feeder spindles. What is that thing? It looks like it's in the way, whatever it is. Anyway, I can't really even tell which way the cotton is coming in. Now, I know that it's coming in on the rollers, but you haven't really told us that. But what this is really missing is the plan view. What is the top-down, the bird's eye view of this? Is it just one camera, or are there two? How far apart are they? How far are they from the feeder spindles or from the module feeder spindles? That kind of stuff. There's a lot of detail missing. You have a good concept, but it's not really a very well-developed solution. You talked about mounting brackets, but where do they mount? I know every gen is different, but you've got to have some sort of idea or plan about how these are mounted on just a module feeder system.
The sides on this one are all the same.
Yeah. Okay. But the main thing that's missing is how do we, what you've got components, you've got cameras and lights, you got lens covers, but is there a monitor somewhere? Is it going to be on an existing monitor, or that would be good, because I'm sure there's a computer somewhere in the gen. Or is there a dedicated monitor? Is there going to be an alarm that goes off? How does the gen manager know when to stop it? So there's got to be more to this solution than just the cameras. So I think, and let's go back to Caleb's part of the presentation. Lots of cameras, not a single picture until we got to the Daniel's part where it was about cost. So really, you're kind of deficient in images to help us understand what this is.
Yes.
All right, so that's the main thing, is not very well developed. Focus too much on the lights and cameras, and not on the whole system. Let's talk about the economic analysis. Yeah, you're, again, like I said to the last team, you've got a solution that is very low cost in terms of the large amount of money that flows through a gen. So that's a great place to be in. So how do you do economic analysis? Net present value, rate of return, payback period. I think what you're going to have to do is go to. Are your slides on this, Wayne? Okay. What I'm going to recommend is that you focus on this right here. So first of all, I wouldn't have mentioned Southwest Farm Press. I would focus on the author, Hughley. Hughley estimates this farm. Okay, so that's the author. I don't care where it appeared, but whoever Hughley is, that's the source. So you're looking at somewhere between 5 and 7 cents a pound. But what you've done is you've projected this over the entire cotton crop. So what I'm going to recommend to you is take just a nominal sized gin. How many bales a year does just a nominal, an average sized gin, how much throughput would they have, do you think? Anybody know?
A year?
Yeah, in a given year.
The one we're being built in where I'm from, they're trying to push on like 100 bales.
100,000 a year? The math works on that. So let's say,
increase.
now there's some gins that only do like 20 or 30,000 a year. And there's some that do like 200, what was the record last year? Everybody set records. Like 200,000 bales a year.
Well, we've got one that's clear for.
Yeah, so let's just use a number like 100,000 bales a year. Well, if the loss due to plastic is 5 cents a bale, you can do the math right quick and say, well, that's $5,000 loss. That's not a lot of money, but now you've got something to put up against your solution, which is going to cost $800, maybe $1,600 or $2,000. So you can do some analysis there.
And I mean, kind of following up on what the ginners think in terms of dollars a bill. Like if you ask them how much is your labor cost in dollars a bill, they can tell you right off the bat. So they think that's the main unit they think in. And so if you just converted this to dollars per bale, that's a number, because they know how big their gin is, and they pretty much know if something costs me X dollars a bale, it's, in their mind, they convert it real fast. So I think that, without worrying about how big the gin is, just get it down to dollars a bale.
There you go. Yeah. So that way it's scalable to any gin can understand that. Okay, my solution's going to cost me maybe 50 cents a bale, but my savings would be, $5 a bale. So they can have something to determine whether or not this is going to be worth it. So that'll help you on your economic analysis. Approach it like that. It's a little bit artificial because that's not really the way this is applied. This average is applied to the whole crop, but it's better than what you got now. So I'd recommend something like that, unless your client or your faculty advisor can point you in a better direction.
If y'all put it in perspective in your head right quick, if that's $25 a bale, you're shooting for 100,000 bales a year. Yeah. You didn't take long to do that, man.
Okay.
Pay that $800 off pretty fast.
So style-wise, your presentation style, you guys are really getting very comfortable in front of the camera, in front of a room, and that's ultimately what we're trying to get. Okay, so you guys are coming along really well. In terms of the content, I've kind of mentioned you need more of a systems analysis of your solution. You need a little bit more teeth in your economic analysis, and I pointed you in the right direction there, I think. And then your presentation needs some more pictures and drawings. So y'all can work on that for the next one. And your client gave you some ideas of the next step in this is the risk analysis, and he's already mentioned, hey, yeah, if we detect some plastic, we got to shut this down, and a worker's got to go in there. Whoa, that's another possibility of somebody getting injured if the gin comes back on. So think about the implementation of this system. Because somebody's got to remove that plastic unless you've figured out a way to do that automatically, which is a whole other project. Okay. Anybody else have any comments?